So today we'll study IP level security protocol called IPSec. We have already studied some ways in which we can provide security to IP, and we have looked at some of the tricks that cyber criminal use to 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 create some kind of security issue. Okay, now this is a protocol that is defined, that is well specified, and it means that it's a standard. Okay, it's a standard. All right, so these are the references that I've used. Okay, so we'll start with IP layer security. And yeah, before we begin the lecture, I will request you to please ask questions, because this is little complicated topic. It takes a while to understand it. I mean, it took me a couple of days, in fact, to understand the protocol, and that too I have yet to understand it fully. It has about 200 pages of draft, so you'll have to go through complete draft if you want to understand it. But it's a, in many books cover this in brief. And one of the books that I've referred is this book by Mark Stamp. Okay, and there is a Selling's book. So these two books have enough information. And of course, I use lectures by other profs for taking up some drawings or some pics. That saves a lot of time for me to make. Right. So now we have to look at security at different levels, right? We have looked at security at Ethernet level. Okay. And then now we are looking at security at layer 3. So this layer we have done. And of course, we have not studied, if we wish, we can do encrypt at layer 2. But normally encryption is not done at layer 2 because it's left to layer 3 and above to do the encryption. Okay, so now layer 2, when we say layer 3, sorry, that's IP layer. What do we mean by that? Essentially, we are taking care of this IP packet. Okay, so these IP packets are sent from source to destination. Okay, and it hops through multiple routers in between. Okay, this IP packet will have, as we studied in last class, source address, destination address, and some other fields in the header. Okay, now source address is usually, for this is what we are using is IPv4 address, and destination address of course is also IPv4 in case we are using IP4. Both are 32-bit addresses. Okay, all right, so now we have packets going from source. Okay, that's your machine or your LAN, to destination. Okay, obviously, and this is your subnet, that's the other subnet, and there is a gateway router here. So your machine sends this to gateway router, and gateway router puts this packet onto next router on internet, and so on. It reaches to the other end, other gateway router. From that comes your LAN, and then it received by you. So that's the method, right? Now you are sending sequence of number of IP packets. Like even in order to send one complete email message, you have to have multiple IP packets going from source to destination. So what all we can do, right? So if we provide security at this level, right, then of course, it provides security at higher level. Okay, that's a transport layer and above application layer. But it is left to transport layer to again provide security for themselves. Or application may think that I need more security, the application can also do something for security. So what can you do to provide security? So you have a machine here, your laptop is connected over local area network to gateway. Your machine is connected through Ethernet, you are running TCP suite, TCP IP. Now through this it goes over cloud or internet through various routers and finally reaches the LAN, where we can say this is a gateway router or LAN, and there is a server here. Okay. So your packet travels over here. So now the question is that what do you do to provide security here? What all you can do? Packet originates from your machine, right? And it's received here. Now you can say through common sense that security will be provided between my machine and the end machine here. That is your machine to server. So we can say we can have machine to machine security. Now what do you mean by security? We have already studied this, right? You can have confidential and integrity plus authentication. So you can do encryption and you do a lot of things for integrity, right? Integrity plus authentication. So you can do, when you say encryption and you are sending multiple packets, then you'll have to think what kind of encryption to be sent and what we can use for integrity. Integrity, we know we can do HMAC or we can do some other things, right? We can also do certificates and so on and so forth. Digital signature. Okay. So that these are the only things we can do. All right. So let's go ahead, right? So what we are trying to achieve, we have already discussed three. We want to achieve confidentiality, integrity, authentication. How to achieve confidentiality? We know by now that we have to achieve it through encryption. That's the only way you can achieve it. Now, are you going to use asymmetric key encryption like RSA? Or would you use RSA? I'm asking you guys question.
No, sir, it will be very slow.
Yeah, very good. It's slow. So we are going to use, okay, we are going to use symmetric encryption. Okay, so like AES or 3DES, etc., we are going to use. Okay, these are choices. Now, can we say that everyone who is using IPSec has got to use AES? Can we say that? No. Some machines may not have AES, right? So you are going to give choices, AES or DES. Now again, what mode you are going to use, ECB, CBC, CDR? Of course, we can define. Say for example, with the AES, we can use CBC, for example. Again, you can give choices. Okay. Now note that symmetric encryption requires shared key. So what kind of method you are going to use to exchange keys? Diffie-Hellman or maybe RSA or something. Okay. Now Diffie-Hellman you are going to use, then what is going to be the key size? You will have defined parameter. Okay. RSA again, key size, etc. you will have defined. Also you have to define how long, what is the lifetime of the key. Okay. Now you have to, in order to achieve integrity, you can use MAC or HMAC. HMAC also uses key, which is symmetric key, a shared key, again you have to generate this and send it to other end. Okay, so these are the things minimum you can think of right now, right now, because we are, from our basic knowledge that we have, lectures we have learned so far, we can say that these are the minimum things we have got to do. Okay, all right. Okay, then authentication we have got to do at what level? Basically authentication, integrity, of course we can say that something that's going through route should not be changed. Okay, and we have mechanisms for that. And in order to have source authentication that you are receiving actually from some source, right, we can use some kind of certificate, digital certificate, right, or pre-shared keys. Pre-shared keys essentially we can use HMAC or MAC. Or key exchange, of course, Diffie Hellman, right? Okay. This point we have already discussed. And when we are generating key, then we have to define the lifetime of the key also. Okay. Okay. Then how frequently we should generate these keys? And then we have to define what is the method to generate these keys. What method you are using? Okay, for example, again we can say it's a Diffie-Hellman or something. Again, we have to define parameters for that, right? Okay, so we can see that there are large number of parameters we'll have to play with about algo, what algo we are going to use. Okay, then what is the lifetime of the keys? What is for example, what is a key exchange method? Now, and then of course, other party may say I don't have certain things, right? I cannot honor that. From source you want certain very high level of security, but server may say I cannot support, I don't have support for that. It means the parameters between the both ends should be negotiated. Okay, so all these provisions we'll have to do. Okay, so now we have basic idea that IP level each packet has to be encrypted. Okay, or it can be, it has to have some authentication mechanism, or it has got to have combination of encryption and authentication. Okay, these are the choices. Then you can say, can we it have this encryption end to end, source and destination, source your machine and server end to end, or it is between gateway to gateway? When we say it's a gateway to gateway, what do we mean by that? Say for the perfect example, you can ask your IT admin guy how they have configured your network. So you have North Campus, right, where your hostel is, or maybe South Campus also, some hostels are there, and there is South Campus, right? So you can run a LAN here, and there is a gateway, and there is a gateway here also in South Campus, right? And in between, now in between here inside the campus, or suppose you have a laptop here, you are sending a packet from North Campus to someone who is in South Campus, or you're logging to server. So now your packet here is unencrypted from your machine. You have a choice. You are not running for your machine to server. You have a choice that in your campus you are running without encryption, assuming that everyone on the LAN is honest, and then is responsibility of gateway to provide security. So gateway can do encryption, authentication, etc. So all security things will happen between two gateways. Okay, so these are the choices that we have. That security can be provided end to end, or gateway, or we can say this is firewall to other end, another gateway or firewall. So what we can say, between two campuses, now we have a virtual private network. First case, when it's end to end, you from your machine, you are connecting to a somewhere in the cloud, some server, then it's again, you can say it's a kind of VPN provided by somebody. You can use VPN provided by various companies, like, okay, all right. So these are the points. Now let's come to IPSec introduction. Now here, okay, we are providing, what we are studying is this one, wherein security is provided at network layer with IPSec. Okay, now see, this security can also be provided, this similar kind of encryption and authentication we can do at transport level or TCP level. Okay, and then corresponding protocol is called TLS, which is very important protocol, /SSL. Now this TLS is used in HTTPS. When you do browsing, then in fact what your machine does is nothing but TLS. Or we can, application wants security of its own, then it can do encryption and decryption, etc., at application layer, right? For example, PGP or MIME, which is email protocol, right? Okay. So we can provide, we can do all these things. That's encryption or authentication, okay, at network layer, transport layer, or application layer. All right. So it depends, what kind of mechanism you want to use. So application of IPSec, as we already discussed, it provides, a tunnel, or it provides secure connectivity from a branch office to main office, or between two organizations. Okay, two branches of an organization, like your campus, for example, IIT Mandi has a campus in Mandi, and then you decide to open a campus in, for example, IIT campus, Mandi campus in Delhi, for example. Then you can connect these two things using a VPN. So basically, it's extension of a large network, extension of a network, right? Okay. Or you can do secure remote access over internet. You are in Delhi, for example, and you want to connect to your campus network. Now, I'm sure your institution would have given you a VPN software, right? So it means that from your laptop, you run VPN, and then all your packets that are going to campus or campus firewall will all be encrypted. Okay, all right. So basically, IPsec allows to encrypt and authenticate, or encrypt or authenticate, or just authenticate. So three options are there: just encrypt all packets, or just authenticate, or encrypt plus authenticate. Do both. Okay, depends on what you want. These choices are again given in IPsec. Okay, all right. So these three things we already discussed. Okay, so what does IPsec, what are the goals of IPsec? It verifies sources of the IP packet. It means that when Alice is sending a packet to Bob, actually Alice is sending it to Bob. It means Alice's IP address is being used. So Bob, or in between, Mallory cannot change the source address of the packet to her own packet, own IP address, right? So it gives integrity and provides integrity and confidentiality. It prevents replaying of old packets. The Mallory in between, if saves the packet, so Alice is sending it to Bob, and Mallory in between keeps saving them. Okay, and then after some time replace them. Okay, now what kind of attack she can do, right? through replay, good number of attacks are possible. We will possibly see later. Okay. All right. So it provides all these three, and of course it automatically provides security for higher layer protocols. So IPSec protocol makes use of encryption, hash, HMAC, redistribution algorithm like Diffie-Hellman, then signature and certificates for authentication. Okay. Of course, a lot of choices, and to user we have already studied this 3DES for symmetric key encryption. MD5 and SHA-1 is basically hash algorithm. Okay, and then basically we use them for HMAC. Okay, and then choices of authenticate or encrypt, or both authenticate and encrypt. This already discussed. Now we can use this IKE, this is the Internet Key Exchange Protocol. IPSec has IPSec internally uses Internet Key Exchange Protocol. Now this is very complex protocol. Okay, for exchanging keys and coming up with understanding between two entities, that what kind of encryption we are going, so what are the key size, what are the time of the key, lifetime of key, etc., etc., right? What is going to be authentication mechanism? All these parameters can be chosen automatically by IKE protocol, or it can be done manually. So this protocol IPSec allow these two things, right? Okay. Now this gives you a picture of what all can be used, right? For example, in order to do encryption can be done using DES, 3DES, or AES. Authentication can be done MD5, SHA, HMAC, and certificates. Key exchange we use Diffie-Hellman 1 or Diffie-Hellman 2 or DHS. Okay, these are kind of versions of Diffie-Hellman. Okay, and then we have a choice of ESP, which is basically encryption only, or encryption plus authentication, or only authentication. Correspondingly, we have header, ESP plus AH header, or AH. Okay, so these are the choices. Okay, so use case is already we have done. We can use it for access VPNs. Say for example, this is a remote office, this is a regional office, this is the main office. So basically we can create a tunnel between gateway and these two. Okay, or we can create tunnel between this and so on, right? Okay, so when we say tunnel, it means that we do encryption plus authentication at the gateway level or firewall level. Okay, or there is a mobile worker who's doing remote working, right, from work from home, etc. They can connect it to their main office through VPN starting from the laptop to the gateway or to the server. Okay, this is again a scenario. This is gateway router. Okay, and this is the laptop or desktop, right? Okay, and this is a normal IP packet that is created by it, right? So IP payload in fact may contain TCP or UDP packet. Okay, now in this net, Ethernet, okay, there is no security. It's not end to end, right? So this, your laptop does not know that there is a security provided, which in fact is provided by gateway. So gateway use IPSec and insert its own header, IPSec header, okay, and do encryption, authentication, etc. And some understanding will be there in IPSec header, okay, and this will go to, for example, this go over public cloud to another gateway. And this gateway, so basically there is a encryption, authentication, etc. is happening between these two entities. So it actually provides a secure tunnel in some sense, right? Okay, and this gateway will do all the checks, etc., decrypt the packet and send it over local Ethernet. So this unencrypted packet reaches to destination unencrypted, and all this processing or encryption, decryption happening between two gateways, these two gateways, right? Okay, so that's one scenario. Other scenario is that there is a user here which can handle IPsec, but there is no gateway available to a person because it's maybe working from home, etc. Right? So from somebody from here who is inside the organization sends an ordinary packet, and this gateway does encryption, authentication of the packet, and then inserts header, etc. And then this packet goes to this person's laptop, and then this person's laptop does the processing. Okay, so basically here it is between gateway to user and user, or it could be from, if both users are working from home, then it could be this kind of IPsec packet will be generated by this user and will be sent for public cloud, right? So essentially we are creating this kind of secure communication. Okay, or this was the earlier case, we are creating a secure tunnel between the two ends. Okay, two gateways. So gateway 1 to gateway 2. Any question up to this point?
Sir,
Okay, yeah.
Sir, this IPsec protocol is essentially a network layer protocol, right?
It actually works on top of IP, but is considered as IPsec. Okay,
Okay, sir.
we'll look at the diagram. We will come to this, right? So see what happens is that TCP generate TCP datagram or head packet, and that has to go into IP packet, right? So in network it creates IP packet, and then we have to do something on top of that. Okay, by inserting IPsec header. Okay, and once this kind of thing is generated, then again it has got to go over IP. Okay, so we'll come to that little later. Please hold on. Huh? Okay, it's your question. I understand what it is. Okay, so this is the scenario which we already discussed, right? There's another scenario where, okay, there's a tunnel created between the two, and we create tunnel using tunneling mechanism, right? Which is basically original packet is inserted inside another packet. So source becomes this, destination becomes this for outer packet, and inner packet is generated by the machine here. So we'll come to this as well. Okay, all right. So IPsec is very complex protocol, you would have realized by now, because it provides lot of features. So it's over engineered. Okay, and it has some problems, right? Basically interoperability problems, which would have been resolved by now because all this is a bit 5 years old slides. So IPsec basically has two main things. First is internet key exchange. Okay, so basically this protocol it uses, this is a protocol. Okay, which essentially does mutual authentication, establishes session key, and establishes security association. security association is between either two gateways or two end users. So now here, when we say security association between a user 1 and user 2, essentially all the parameters user 1 has decided for encryption authentication must be some must be understood by user 2 to process it, right? So it must send some kind of number which we call a security association, which gives a relationship between for this logical connection. Okay, so that we also send in a packet. Okay, so IKE creates all this understanding between two users. What are they going to use? And in the beginning, so once that understanding is there, then actual IP traffic, whatever packets are being sent, are processed. Okay, all right. Okay, so now we'll come to some of these things little later. So basically the choices are authenticate only. When you are using only, we say that IPSec provides only authentication. Then we have a choice whether it's between end machine to end machine, one laptop to another laptop, or one gateway to another gateway. Or we can say we are going to use this IPSec is going to use encryption with authentication. This is the most powerful, or encryption only without authentication. Again, there are two choices, end to end or gateway to gateway. Okay, so basically authenticate only is one choice, end to end, and then gateway to gateway, and then encrypt only end to end, gateway to gateway, or encrypt plus authenticate end to end or gateway to gateway. So these are the choices. Okay, and correspondingly we call it, when we are going to authenticate only the IP, we are putting extra header, extra shim or extra part in the header is called authentication header, and we are going to use encryption plus authentication or encryption only, then we call it ESP header. ESP stands for encapsulating security payload. Okay. Basically it does encryption and authentication, or encryption plus authentication, or encryption without authentication. Okay, encryption and authentication. So all right, this is only authentication. Okay, and then we have again the two modes where we call it transport mode, which is end to end, and tunnel mode is gateway to gateway. So this is end to end. When we are going to encryption and authentication, then it's end to end, or it could be gateway to gateway. All right, so these are the choices. Okay, now so basically this, the chart says, or sorry, standard says that we are going to use encrypt and authenticate this, or we are going to use this. And then of course the draft also defines what is IKE, Internet Key Exchange Protocol. Now we will not study this part because it will take a lot of time. So we'll focus only on encryption and authentication and with IKE. All right, and we'll look at on both transport and tunnel mode. Now transport mode, as we have seen, is end to end. This one here. Okay, tunnel mode is between two gateways. Okay, it must be clear to you. Okay, when we say we are using tunnel mode, here what we are receiving is unencrypted, and similarly here is unencrypted. Okay, it's only responsibility of gateways to do encryption and decryption. All right, now default mode is tunnel mode. Okay, because encryption, because you always want confidentiality. Okay, all right, so now let's look at transport mode, and then we'll study tunnel mode. Okay, so let's not go through this slide, but let's directly jump into transport mode. Now, transport mode, as we discussed earlier, is between endpoint to endpoint, these two. Okay, all right, it means that it's a responsibility of this node to modify IP packet by putting some extra information such that other node can decrypt it properly. Okay, so there is not IP packet only, but IP packet with additional fields. Okay, so now let's look at it. So transport mode protection extends the payload of IP packet. It changes the payload of IP packet. When we say IP packet, then of course it may include datagram that we have received to TCP or UDP, or it could be ICMP packet. So now when we say that two endpoints, okay, or users or laptop of users, laptop for example, are running transport mode, then they should do all the security checks by themselves. This is their responsibility. It means that your laptop must have capability to generate, do encryption and do extra processing. And similarly, the other end must have understanding with the sending laptop what all can be done for decryption and authentication. Okay, so it's always end to end. All right. Okay. So now let's look at this IP header and payload. What is this payload then? Something that we have received from TCP. This TCP packet will come inside here, right? That becomes payload for IP. Okay, now what we want to protect? See, if remember, we have studied authenticated encryption, right? We studied these concepts precisely. Okay, now if you encrypt everything, then source address, destination address, which is the most important thing, will also get encrypted. Then how in between routers that are on the way will know what is the destination address? Because they don't have key. Key is always end to end. Okay, it means that IP header has got to be in plain text. Clear? If it is in the plain text, then how do we protect it? If mallory changes that, we should be able to find out that mallory has changed, destination address or source address or something like that. Then it means that we must have some kind of what? Check, right? What are we going to check here? What mechanism we are going to use? That something has changed in header. How do we authenticate it?
Sir, checksum.
How to check? Yeah, we can have either, similar mechanism. We can use, we have used hash, right? We can hash encryption. What do you call that? Okay, Mac, we can use HMAC to check integrity of this. Okay, we can use HMAC. Now, when we say HMAC, it means that it's a keyed one. So key must also be available at the other end. Okay, who will send the key to other end? For not for the encryption of this part, but integrity check of this or some other part of this. There must be a key. So there are two keys, one for encryption, one for HMAC, for example, K1, K2, and these are all generated by IKE, Internet Key Exchange Protocol, right? Okay, all right. So now let's go back again. So now in transport mode, what we are going to do is that we are keeping this as it is, okay, and inserting a IPSec header, and then this is the payload. So this header is inserted. Okay. Now this is very efficient method, but because we are just inserting this. But what are we achieving through that? Of course, we will have to have encryption and authentication over some fields of that. This diagram simply shows we are inserting a shim or a part by at this place, right? So this payload comes here, header is here, and in between we have IPSec header. Okay. Now, so the question that you have asked earlier is something like this. So application generates data, then application wants to use TCP, for example. It can also use UDP, but let's assume it's using TCP. So TCP header comes here. This goes into IP. This is what your laptop is generating. Okay, then laptop has got to do more processing with IPSec. So it will move this original header and then insert ESP header here. Okay, and then at the end it will have ESP trailer, and there is a authentication. So when you are using encryption plus authentication, then this part is for authentication and encryption is done over some fields, which we'll come to know later. So basically this ESP header, what should it contain? It contains some indicator, which we'll study in the next class. Okay, some index. Okay, and the sequence number and IV. Okay, so what are you understanding from this? The SPI will tell what this gives the index of some policy that both source and destination have agreed. Okay. So now once this number is received at the receiving end, let know what kind of decryption is to be used or what kind of authentication mechanism is to be used. Okay, so let's just restrict our discussion with SPI only to this number. What is the sequence number? Why do we need sequence number? We are generating a sequence here. We are doing this to avoid replay attack. Okay. What is IV? We know this, right? We have studied the symmetric key encryption. What is IV?
Initialization vector.
Yeah. So we are using it for what here? We are using basically symmetric key encryption. Okay. Then IV is required in CBC mode or some other modes, right? So this IV will be also part of this one. Okay. What trailer will contain? It will contain pad. Why do we need pad? Again, go back to symmetric encryption. We need pad in the last block, right? So the that pad comes here. Okay, basically some insert some zeros or whatever, some numbers, right? And then authentication, keyed hash. Keyed hash is what? HMAC basically, or MAC or HMAC. It will be, value will come here. Now we'll have to see now, still we are not complete. What part of this is to be encrypted, and such that destination node based on SPI can decrypt that part, and then HMAC can be used for authentication. So now this diagram tells you exactly what is happening. So this is original IP packet, which contains in fact TCP header and data. Okay, forget about TCP, etc. right now. So now we are inserting here this ESP header. Original IP header comes here. and this is the data that we have received from top, okay, which is TCP header and data, and then here we are adding ESP Taylor. So this part, which is this part of IP packet that we have generated, or which is essentially a TCP part, TCP packet, plus ESP Taylor is encrypted. So something that's shown in the green here is encrypted. Okay, and what is authenticated, or basically authentication number we generate? We look at ESP header and complete packet, IP packet that we have received from top, plus ESP Taylor. For all this area we do integrity check, right? Basically we generate seed hash using HMAC or MAC, depending on what we are doing. Okay, and put it here. All right. And then as we discussed earlier, ESP header will contain SPI's security parameter index, sequence number, and IV. And this Taylor will contain padding, pad length. This is required, as we have seen in case of mode of operation in symmetric encryption, and the next header. Well, why next header is required? Okay, what we have, okay, I will just how do you know, how the receiving node knows that it has received this packet, modified packet? What it will, something that is coming from top, how does it know is corresponding to IPSec? It will only look at, it has some header, and then in header there is a field called type field, right? Which says what is inside this area or payload, where we can define here TCP, UDP, etc. Okay, now here type field contains TCP or UDP, then this whole packet, if this original field, type field, contains TCP, then whole this area is considered as TCP payload, right? So it means now this next or type field must be changed in this one, which we call original. Actually is not original, but original with some modification. So next field will become corresponding to IPSec. Now this, when receiver reads this type field, it knows that this packet is IPSec packet. But now this packet is IPSec packet, but actual packet that it contains should be known, right? It, whether it's a UDP or TCP or something else, it should know. Where does it know? Then we say that we are putting another field here, which is next header field, which will say no, something which is here is TCP. Okay, that's the reason we have next header field. Okay, all right. So please go through this, you will understand. Okay, all right. So if you look at this diagram, okay, this is the original IPv4 packet. Okay, now here we are using payload of this content TCP. So the next field here, or sorry, or type field or protocol field says that TCP. But once we modify this to IPsec packet, okay, then the next field here become ESP field. It means that now this is ESP. Okay. Okay, and then we should know what this is, whether it's a TCP or UDP. Then at the end we define a field, okay, which is part of ESP trailer. So this is ESP trailer. Here this field size is TCP, essentially points to this one. All right. Okay, so this is how we interpret this. So please go through this diagram. Exactly same thing is depicted here. I have just put in taken diagram from some other source. Okay, all right. So now we will study from here onwards in the next class. So just give you a little some idea that what we have studied here is end-to-end mechanism between one laptop to another laptop. Okay, and all this packet creation, this kind of packet creation is to be done by endpoint and also to be interpreted by another laptop, and with this understanding. Okay, all right. And this SPI field here, security parameter index, tells you what kind of how the packet should be processed based on previous understanding between two endpoints. All right. In tunnel mode, we create a tunnel here. So here the network and the network here, the machine here, for example, doesn't know or doesn't want to do any encryption, etc., or IPSec, etc. Right? It says that I don't care about it. Then it's a responsibility of gateway router in, for example, in North Campus and South Campus to create tunnel in between, because the packets are not going through a private line but is going through internet. Okay, so basically it provides encryption and authentication by creating some kind of tunnel. So it says that Alice is connected here, there is no IPsec, Bob is connected to other end, no IPsec, but tunnel in between. IPsec provides security, okay, between Alice firewall and Bob's firewall, or gateway, Alice gateway or Bob's gateway. Okay, all right. So now what we do here is, interesting thing is that we take IP packet that's coming from top and put this inside another IP packet, and it means that now we have to attach new header, etc., etc., and original IP packet fully can be encrypted, including header, etc. Okay, when you want to fully encrypt it, then nobody knows, right? Nobody actually knows that is all encrypted packet inside. Okay, so we'll study this mechanism in the next class. Any question? Note that this is most complicated protocol in terms of security, right? Because it gives a lot of choices, etc. So hope you are able to understand something, and when you go through PPTs, I am sure you will understand more. Okay, any question? Did I answer the question you asked? Okay. All right then.